Hello everyone. I am pleased to welcome you to the next lesson dedicated to working with the Topoplan module. In this lesson, we will look at surface editing and the procedure for drawing a topographic plan. Let's continue based on the previous surface we imported in the last lesson. In the Topoplan tab, let's use the Add Mesh Edge command. In the command line or on the cursor, a prompt appeared asking us to specify the first point of the edge. Let's specify it. Now we need to specify the second point. Let's specify it. As we can see, a new edge has appeared. Note that an edge can only be created when there are large green and red points indicating where it will be located. Now let's flip the edge. This is possible using the Flip Edge command. Activate the command, and we will be asked to specify the edge to flip. When hovering, the area where the edge will be flipped will be highlighted in blue, and the edge itself will be marked with a thicker blue line. Edges can be deleted using the Delete Edge command. Activate the command and pay attention to the command line. Let's use the Edge option, which will allow us to directly select edges and delete them. For example, click on several edges and delete them. If necessary, we can delete many edges at once by activating the Frame option. You can add points to our mesh using the Add Point command. Activate the command, and a prompt will appear asking us to specify the mesh to which the point will be added. Specify our mesh, and now we are asked for the new point's position. Arbitrarily place our new point. Pay attention to the cursor or command line. The prompt indicates that the UCS elevation is 62.40. The mesh elevation is 62.40, and we are asked to specify the point elevation. Let's specify, for example, 100. Now, setting the front view, we see that one point clearly stands out in height. We can remove the point from the drawing using the Delete Point command. Activate the command, and in the command line, we can see the vertex parameter, which allows us to directly select points or use a selection box. Select any point on the surface using a selection box, and we see that along with the point's deletion, the mesh has also transformed. The Move Point command moves the surface point and automatically rebuilds the triangulation. Let's use the command. Specify the point to move, and then the new position of that point. We are also asked to specify the elevation of this point. Let's not change it, and apply the changes by pressing Enter. The Change Elevation command allows you to change the z-coordinate of the surface vertex and automatically rebuild the triangulation. Activate the command, select the point, and specify the new z-coordinate value for this point. Now, rotating the drawing, we can see that the point has changed its height. Undo the changes using Ctrl-Z. If gaps formed during the creation of the tin surface or in the process of editing it, the Mesh Seal Holes command allows you to fill them with missing edges. Let's create a gap. Activate the command, and we can see that the area with the gap is highlighted in red. Change the Automatic Filling of Holes field to Yes, and leave Remove Error Highlighting unchanged. Confirm the changes by selecting Yes. As we can see, the triangulation has occurred, and our areas with gaps are filled with edges. The Add Structure Line command allows you to add a structural line to the selected surface, automatically rebuilding the triangulation. In our case, a structural line is a specified line that should become a side of the triangle in the triangulated system. To do this, create two layers named red and yellow. Set their thickness and corresponding colors. For convenience, let's disable 3D snaps and dynamic UCS. Use the Polyline tool to draw two open areas. Change the value in the elevation fields to 62 for the yellow line and 64 for the red line. Activate the Add Structure Line command and specify both of our polylines as structural lines. In the settings, set the structural type field to Standard and the Project Profile On field to WCs. As we can see, the triangulation network has changed. Let's also take a look in isometry at how the mesh has changed. We can also change the visual style and enable line thickness. The command has been enhanced with the ability to construct retaining walls. To do this, draw a sketch using the Polyline tool. Then activate the Add Structure Line command again and select this line. Confirm the selection by pressing Enter, and now in the settings, set the structural type field to Retaining Wall. In the Get Elevation From field, you can specify where the labels will be taken from Structural Line or Mesh. Let's leave the value Structural Line. The Set Wall Height field allows you to determine how the height of the retaining line will be set for the entire length or for each section separately. Let's set the value to Separately in this field. As we can see, the last line disappeared, meaning we will now need to specify the height for each point of the line. Confirm the parameter application by selecting Yes. Now specify the side on which the elevation will be formed for this structural line. Next, the command will require specifying the height for each structural point. Let's specify heights with a step of 10 units, starting from 60. We see that a semblance of a wall has formed. Let's draw an arbitrary rectangle. Now, using a rectangle, specify the area to be trimmed using the Cut Mesh command. In the Specify Closed Contour field, set the parameter to Selection and leave the other parameters unchanged. Confirm the settings by selecting Yes, and now specify our pre-designated area. We see that our mesh now consists of two separate areas. You can always get more detailed information about the settings by pressing the F1 key. Let's consider two more interesting commands. The first one is the Simplifying the Mesh command, which helps reduce the number of triangles in the selected surface. Specify the surface, and now in the settings on the left, specify the required parameters. Let's set the value to 2000 in the Target Faces field. As we can see, the value in the % field has changed. We can also change the value in this field, and depending on this number, the number of faces to be obtained will change. Let's leave the other settings unchanged and apply the parameters by selecting Yes. As we can see, the mesh has been simplified. Let's undo the changes using Ctrl-Z. Now let's look at working with the Classify Mesh command. The command is used to separate the mesh into classes. For example, if you need to separate road surfaces from lawns. For classification, polylines need to be created in the drawing, along which the mesh will be cut. Let's draw them arbitrarily. Now activate the command and confirm the settings by selecting Yes. The program will ask us to select the polyline within which the points will be classified. Press Enter, and we see that the mesh inside this area has moved to the line layer and represents a separate object. Let's undo the changes using Ctrl-Z. Let's complete working with the surface by generating contours, or isolines, from the prepared and edited surface. Use the Create Contour Lines command. Let's select the mesh. In the Settings panel on the left, set Contour Smoothing to Yes. Additional parameters will appear. set the value to 50 in the smoothness level field, and yes for avoid contours crossing. In the intermediate contour lines group of parameters, change the contour color. For example, set the color value to 42. For the index contour lines group of parameters, set the color value to 34. Confirm the application of the parameters by selecting Yes. We see that isolines have appeared, but for better clarity, I suggest hiding the tin surface. Let's also turn off the geopoints layer. Continuing to work with the terrain, let's add labels and BERGSTRICHes to the contours. Before launching the commands for generating labels and BERGSTRICHes, it is necessary to determine the scale of the final drawing. We will prepare the topographic base at a scale of 1/1000. Set the required scale by selecting the desired value in the Toposcale drop-down menu. First, let's add BERGSTRICHes. Call the BERGSTRICH command. Apply the changes by selecting Yes. In the command line, the program will ask you to specify the location of the BERGSTROKES. Place them in several locations. Next, add labels using the Contour Lines Label command. Apply the changes by selecting Yes. In the command line, the program will ask you to specify the location of the label. Label several contours. If there are contours on the drawing or they were drawn incorrectly, they can be deleted using the Delete Contour Lines command. Undo the changes. Let's look at the procedure for drawing a 2D slope on the drawings. This can be done using the Create 2D Slope command, which allows you to create various types of slope symbols, cliffs, and retaining walls. Activate the command. In the settings, you can see the slope sign parameter, which can change the display of this slope on the drawing. Set the value in this field to 280 stone retaining walls, leaving the other settings unchanged. Specify the points of the slope's top, and then the slope's base. We see that our slope is displayed on the drawing. This command can also be used to indicate a hill. After confirming the settings in this command, select the peak parameter in the command line. Now specify the top point of the slope and then the base points of the slope. Lines indicating the slope have appeared. In the drawing, the slope is selected as a single set of objects, parts of which can be moved. Let's also try to create a 3D slope. The program constructs a three-dimensional slope based on the surface or objects. After starting the 3D slope command, configure the slope type and characteristics in the panel. The parameters vary depending on the slope type and the method of indicating its edge. Set the construction method field to From Object and the step to 5. Apply the changes by selecting Yes. Specify the upper edge of the slope and then the lower edge. Lines describing the relief of our surface appear. In some cases, it may be necessary to create a profile line. The Create Profile Line command is used for this purpose. It allows you to create a 3D polyline object that lies on the mesh and accurately follows the terrain of its surface at a specified location. To create the object, a triangulated network is required. Activate the command. Select the UCS option in the Project Profile On list. The profile line is defined by specifying several nodes, with the option to automatically close its ends or extend them to the edges of the mesh. Profile lines can be used to place surface elevations along routes, generate reports, etc. Let's take a look at the result. I also suggest changing the visual style for clarity and removing the line at the base of the retaining wall. Similarly, we can draw a polyline and project it onto the surface. This can be done using the Project Line to Mesh command. Draw a polyline and use the command. Select the UCS option. Specify our line and see that it is projected onto the surface. This concludes our lesson. In the next lesson, we will continue to explore the Topoplan module on the nanoCAD platform. Thank you for your attention. See you in the next lessons.